All right, so for this problem, it says the table shows the world population of the Iberian lynx in 2003 and 2004. So we're going to use this table here. And it says if this trend continues and the population is decreasing exponentially, how many Iberian lynx will there be in 2014? So they tell us in the instructions that this is an exponential equation. So we have two formulas that we can use. A sub t is equal to a times b to the x, or a sub t is equal to a times 1 plus r raised to the x or t value. So let's just say t for time. All right, so then from here, what we will have to do is we need to solve for this b or solve for the rate. Now, when we're given this information, what you should do first is we're going to create ordered pairs from these. Now, rather than using 2003, since that's the initial starting time of this period, let's just say that this was our first year or the beginning year. So we'll say at year 0, so it's the beginning of time, and there's 150. So then this way, 2004, we can just say 1 and 120. It just gives us a little bit easier numbers to work with. So now what we need to do is we need to solve for b, or we can solve for r. Now there's a few ways that you can do this. I'm just going to go over one way. If you would like to know some of the other ways, then after class you can ask me and we can go through it. But we're going to find the percent of change. All right, so what we need to do is you take your new number that you have, the new number that we started with. So that means our new number, it went from 150, it started from 150, and then it went to 120. So we take 120, and we subtract our original number from it. And then we divide from the original number. So it'll be over top of 150. So this is then equal to negative 30 over 150, or this is then equal to negative 0.2. So that means our rate of change, negative 0.2. All right. If you would have done 150 minus 120 divided by 150, as long as if you see that this is a decrease when we go from 150 to 120, you would have gotten a positive 0.2, but since you see it's a decrease, you know you'd have to subtract it out. So that means our r we solved for already. We already know our r. So now the last letter that we need to solve for is this a. And we know that when x is 0, our y value is 150, so we can plug that in. So we can say 150 is equal to a times 1 plus negative 0.2 raised to the 0 power. And we know that anything raised to the 0 power is equal to 1. So this will simplify to 150 is equal to 1 times a, or a is equal to, not b, a is equal to 150. So we solved for our r. We solved for our a. So now we can plug into our equation. So now we came up with the equation. It's a sub t is equal to a, which is 150, times 1 plus negative 0.2 raised to the t power. And then we will simplify this just to make it a little bit easier. So a sub t is equal to 150 times 0.8 raised to the t power. All right, so this is our formula. Now it asks us not only to come up with the exponential equation, but to figure out what is the population in the year 2014. So to do that, we need to use this chart, all right? Or we need to think about how we labeled our years. So in 2003 was 0, 2001, 2004 was 1. So that means the year 2013 would be equal to 10, and 2014 will be equal to 11. It's 10 more than 2004, so it'll be 1 plus 10 is 11. So all we need to do now is substitute 11 in for t. So a sub 11 is equal to 150 times 0.8 raised to the 11th power. And now we have a sub 11 is equal to 150. 0.8 to the 11th power is approximately 0.0859. Now I rounded it there. And then we multiply that by 150. So then we get a sub 11 is approximately equal to 12.88, or we would say that there would be approximately 13 Iberian lynx left. right? So that means in the year 2014 that there would only be approximately 13 left. So this suggests if it stays on this same path, so if there's nothing that we do to change to try and help this animal out, that by the year 2014 there's only going to be 13 left. So this is creating our own exponential function and then using that to solve a problem as we did here. All right, that is it for this video.